You need to know that the integral of e to the u is e to the u plus c, right? And then the other one that I want you guys to know is a to the u. So the integral of a to the u. This is the one where, if you guys remember, it's like this. A to the u over ln of a plus c. So it looks like this. That's that. Now the ones that you don't have to memorize, these are the ones that are given. So they're right here. So the integral of tangent x dx equals negative ln cosine of x plus c. Integral of cotangent of x dx equals ln sine of x plus c. You can write those down. Again, I'm going to give those to you guys. Integral of secant of x equals ln secant plus tangent plus c. And I'll probably have them just on the Promethean board for you guys. So secant of x dx negative ln cosecant of x plus cotangent of x plus c. So these are the ones that I will give to you. I'm not going to make you guys memorize. Just make sure you guys know these guys along with the integral rules from last time. So leave that there for a second. And I'm going to get a separate sheet of paper because I write really big. All right, so let's go ahead. It says find the antiderivative. So we'll start with number 1. And again, it's kind of like I used to do just one big integral test, and then it was like too overwhelming, and my kids were just very overwhelmed. So this is why I kind of split it up into 2. So we'll start with the first one, the integral of 5 to the 5th root of x squared dx, right? Now I'm going to write this on my own sheet of paper. You might be able to fit it. It's up to you, whatever you want to do. I write big, so I'm going to do it on a separate sheet of paper. So for this one, I'm going to rewrite this as the integral of x to the 2/5 dx, right? And again, this is nothing new. It's just practicing more integration. So this is going to be x to the 2/5 plus 5 over 5, right? Over 2/5 plus 5 over 5 plus c. So that gives me x to the, what is that, 7/5 over 7/5 plus c. So my answer is 5, 7, x to the 7/5 plus c. If you guys can get from here to here to here, I'm totally fine with that. Also, make sure you guys put your plus c. I had somebody that missed plus c. Remember, that's worth like 1 point. I had somebody last test miss plus c for all of them. So that was a solid like 15 points right there. All right, look at number 2. So number 2 is a little strange. This one says dx, x ln of x. What do you think your u should be, guys? Say it again. Yeah, no, so what I would do is I know that the derivative of ln of x is 1 over x. Does that make sense? So try to set that as ln of x. Does that make sense? So then your du would be 1 over x dx. Does that make sense? Oh, I went the opposite way. Oops. Just kidding. This is number 3. You're like, Forness. I'm going down. Sorry. I'll do that one over here. So then to get rid of the x, this is going to be multiply both sides by x. So I get x du equals dx, right? So I'm just going to go ahead and replace. I have dx is x times du. And this would be x times u, right? If I substitute it, so I substituted my dx, which was x du, and then that stayed there, and then my ln of x was just u. So then you guys can see what ended up canceling. The x-is, this becomes the integral of 1 over u du. What's the integral of 1 over u? ln of u, right? Plus c. So in this case, this would be ln of x plus c. That was number 3, so I guess we're going the opposite way. All right, let's look at number 2. I'll do number 2 over here. So how I would do this one, this is e to the 3x minus 5 over e to the 3x, right, dx. I would split this up and do a little I heart math. Watch, I heart math. Math hearts me. So it looks like this. E to the 3x over e to the 3x. And I'm going to split it up into 2 parts. Dx minus the integral of 5 e to the 3x dx. Looks like that. So I did this guy over this guy minus this guy over this guy. Then this right here is just 1, right? This guy right here is just 1. So you get the integral of 1 dx minus, bless you, factor out your 5. And then I'm going to bring this e up. So you get e to the negative 3x dx. Looks like that. I'll pause to give you guys some time to catch up. And so you're going to take the integrals separately, right? Right here, the integral of 1 dx is just x, because the derivative of x is 1. Here I have minus 5, and I'm going to do a little u sub right here. My u would be negative 3x. My du would be negative 3 dx on the side, right? I picked this to be my u right here. So du over negative 3 equals dx. So if I substitute, this becomes e to the u times du over negative 3. Review. Yeah. No, you're good. It's on the, it's kind of sticking out. Right there. Yep, no, up. Right there. Yep, nope, down. Down. No. All the way to top. Sorry, I think it's that one. Does that say review? Yes, okay. So then, guys, I'm going to pull out this negative 3. Does that make sense? So I get x, a negative is a positive, and 3's on the bottom. So it'd be 5/3 integral of e to the u du. And so for this one, this would be x plus 5/3 e to the u plus c. And I'll just plug back my u, which is negative 3x. So that was number 2. That was number 3. Sorry, we're kind of jumping all over the place. So we did number 3. Let's do number 4. So number 4, I'll do it right here. I have the integral of ln of x to the 5th over x dx. What do y'all think your u is going to be? I wouldn't do the whole thing. I would just do it because this will be a u to the 5th power, but it would just be ln of x. Because you can take the derivative of ln of x to be what? 1 over x. So I would set it equals to just be ln of x. And you can try it and see what happens. So then my du here would be 1 over x dx, right? But then I'm going to multiply both sides by x. So x du equals dx. So when I substitute, I get u to the 5th, right? Because you want a power to be able to take the integral of a power, and then your x is still chilling. And then my dx is going to be x times du. And so this is nice because my x's cancel. And guys, a lot of it's just practice, trial and error. Even sometimes I look at a problem like, ooh, I don't remember how to do this one. I kind of have to even me, you know, sometimes trial and error with your u's. So now you're left with the integral of u to the 5th du. So that's going to be u to the 6th over 6 plus c, which gives me 1/6 ln of x to the 6th plus c. So there's number 4. Let's go over here to number 5. I'm kind of going back and forth. All right, so I have x times e to the x squared plus 1 dx. What do y'all think? What's a good u? Or not 2x plus 1, but x squared plus 1? Yeah, that's a good one. Because again, when I take the derivative of that, ooh, I see that x there. That's probably going to cancel, right? So du would be 2x dx. Let me zoom in. Solve for dx. So I'm going to divide by 2x, bless you. So du over 2x equals dx. So when I'm rewriting, always plug in your u. So my x is chilling. This is going to be e to the u times du over 2x. So I can see here my x's cancel, right? And I'm going to go ahead and factor out that 1/2. So I get 1/2 e to the u du. And that's nice because we know that e to the u, the integral of e to the u, or the antiderivative e to the u, is just e to the u. Plus c. So what is my u? My u was x squared plus 1 plus c. Ta-da! All right, any questions so far? Are we good? All right, so let's go to number 6. This one I have the integral of e to the square root of 5x plus 7. I'm trying to make sure dx. I would set my u to be the square root of 5x. Remember, the x is not underneath the radical, so be careful with that one, right? So I would set my u to be that. And remember, the square root of 5 is just a number, right? You plug it in, you're going to get a decimal. So my du would just be the square root of 5 dx, right? So to get dx by itself, it's going to be du square root of 5 dx. Yeah. Zoom out. Which one? What number? 3? 2? Got it? No, you're good. So let me go ahead and substitute. This is going to be the integral of e to the u times your dx would be du over the square root of 5, right? So it's like this. And it's okay. I'm going to go ahead and pull the 1 over the square root of 5. Remember, it's on the denominator. Now, some of you guys are like, oh, no, we have a square root on the bottom. I don't care. It's calculus, right? We can do that. AP test does not need us to rationalize. They don't need us to simplify. So you leave that on the bottom. It's totally fine. So the integral of this would be 1 over the square root of 5, e to the u plus c, and that's a beautiful answer. You're just going to plug your u back in, which in this case was square root of 5x plus 7 plus c. And again, most of the time these are multiple choice, so they're going to leave it like that. They're not testing you guys to simplify. Now, if it's like certain little things, they usually don't leave it negative exponents. If it's a negative exponent, they'll make it positive. But square roots, they would actually rather you leave it like that. All right, let's look at number 7. So I have the integral of e to the 3x divided by 1 plus e to the 3x. Now this is not an I heart math. Do you guys see the difference between this one? Right? Because here, this would be an I hate math. If I did this over this, this over this, it's kind of like if you had 3 over 2 plus 4, right? That would be 3 over 6, right? Which is 1/2. But if you break this up to be 3/2 plus 3/4, that's not the same thing as 1/2. Does that make sense? You guys have to be careful. Don't do I hate math. And this is how I survived college. Like if I was ever unsure on how to simplify things, I always just like plugged in numbers. Like, can I do that? All right, so let's figure this one out. I'm going to try, so if I make this to be my u, that 1 doesn't go away. Let me, what do I want to do for this one? Let me try making this whole bottom part my u and see what happens. Because if this my u, then I'm not going to get rid of this bottom part. So let me try making the whole denominator and see what happens. So then this would be du, right? This would go to 0. This would be 3e to the 3x, right? Then that's dx. You'll see that. But if I solve for dx, this would be 3e to the 3x equals dx, right? du over 3e to the 3x. And I think that's going to work. Because if I make this whole thing my u, then the e to the 3x that I can kind of already start envisioning is going to cancel. And again, if you're not sure, like, make your u 3x and see if things cancel, right? So in this case, this would be e to the 3x is chillin'. This was my u, right? The whole denominator. And then this would be du over 3e to the 3x, right? Do y'all see that? And then I can clearly see, oh, I picked the right u. Because this guy, let me change my color. Yeah. Blue, light blue. This guy ends up canceling with this guy, and then I factor out the 1/3, and then I'm left with 1 over u du. And I know that 1 over u is ln of u plus c. Y'all see that? So, oh yeah, that's nice. So 1/3 ln of my u would be 1 plus e to the 3x. Right, put it back in. Don't forget those absolute value bars. Plus c. So it just looks like that. I'll pause to let you guys catch up. Number 8 kind of looks similar. Let's look at number 8. So that one, I have the integral of 5 to the 2x, right? So instead of e to the u, now it's an a to the u. So let's make our denominator u, right? See what happens. So this would be du, right? And then this is an a to the u, right? The derivative of 1 is 0. If you guys remember, the derivative of 5 to the 2x, right? Do you guys remember what that one is? It's ln of 5, so you're right, times the derivative of my power, which was 2, times the function itself, dx. So that's the derivative of a to the u. It's ln of 5 times the derivative of the function, which is 2, times the function itself. And that's all being multiplied by dx. So if I want to get dx by itself, I'm going to divide by ln of 5 times 2 times 5 to the 2x, right? What I do to one side, you do to the other. Is that 5 to the 2x? This whole guy cancels. So du over ln of 5 times 2 times 5 to the 2x equals dx. So I'm going to substitute that, right? This was my u. I set this guy to be my u. So that means the 5 to the 2x is chillin'. This is my u, and then my dx is du over ln of 5 times 2 times 5 to the 2x. This one looks so crazy. This is the type of problem where I'm like, makes me feel smart. I'm like, whoa. I feel like my parents can't even solve this one. All right, what cancels? Y'all see it? Yeah, this guy cancels with this guy, which is good. That means our x's are away. Remember, these are constant numbers. So I'm going to factor them out, and I'm going to rewrite it different, or 2 times ln of 5. And then you end up getting 1 over u du. Whoa. And I know what the integral of 1 over u is. The integral of 1 over u is ln of u plus c. So this becomes this, 2 times ln of 5. My ln of u, 1 plus 5 to the 2x plus c. Wasn't that so fun? Y'all are like, no, that's crazy. I'll leave that up there for a little bit. Whoa! Are we good so far, guys? Yes, yes. All right, let's go to number 9. I'm going to go to the back over here. All right, so number 9, I have the antiderivative or integral of 4 over e to the 3x dx. What I would do for this one, guys, is I would pull out that 4, always pull out the constant, and then bring the 3 to the x up. So it becomes negative e to the negative 3x dx. It looks like that. Because you're trying to either make it to some type of rule that you know, like the power rule, the 1 over u rule. And then I want to do my u to be negative 3x. Right, it's the exponent. So du would be negative 3 dx. Divide by negative 3. So when I substitute, it looks like this. E to the u dx is du over negative 3. From there. So then this becomes, if I factor it out, this becomes negative 4/3 e to the u, right, plus c, when I take the integral of e to the u. And then go ahead and just plug in your u, right? So this would be e to the negative 3x plus c. Ta-da! So there we go. There's number 9. And a lot of times, guys, usually when you have these quotient rules, usually it's your whole denominator. Now, sometimes it's not. Like number 3, it wasn't your whole denominator. It was ln of x. But you usually want something to cancel. So look at number 10. Right, this one's the integral of 4e to the 3x divided by e to the 3x plus 2. I'm going to set my u to be the denominator. Right, now watch what happens. If I do du, this would be 3e to the 3x dx. And this is good because then I'm going to divide by this, and that's what I have up here. So I can kind of see, oh yeah, that's what I want to cancel out. So this would be du over 3e to the 3x equals dx. It's like chess. You're trying to like manipulate your equation to cancel things out. So I'm going to go ahead. Well, you can leave your 4 in there. Probably should have pulled them out, but he's okay. So that's still in the numerator. This whole thing is what I made my u for the denominator. And then this is du over 3e to the 3x. So there we go. There's my dx when I substitute. If you guys see these guys right here, I'm trying to find a red marker. Here's the color. These guys cancel. I'm going to pull out my 4/3, so then I get 1 over u du. And I like 1 over u du because I know what that is. That's ln of u, right? So 4/3 ln of u plus c, which my u, I'm going to put my little bars, e to the 3x plus 2 plus c. Ta-da! All right, number 10 and, or sorry, that was number 10. Number 11 and 12, let's be smart, okay? Like, make it easier for yourself. So this is the 10 raised to the log base 10 of 5x minus 2 dx. Y'all see something? What cancels? The 10 log 10, that's the sad face rule. Do y'all see it? Bloop, bloop. Sad face rule. That cancels automatically. Anytime you have a power, right, a number raised to a log power with the same number, it cancels. So then this is just left with the integral of 5x minus 2 dx. And you're going to split that up. I had kids that on their test got to this point, and then they're like, now I don't know what to do. And I was like, no, the easiest part. So split this up. 5x dx. It's kind of like when we took the derivative, right? You just split it up into 2 parts. This becomes 5x squared over 2. This becomes minus 2x plus c. We're done. Or I would write it like this because I like this prettier way. Ta-da! That's my answer. Same thing for number 12, right? Look at number 12. So you have the integral of e ln of 9x squared plus 1 dx. Oops, the dx is supposed to be down here. Same thing. ln, guys, is the same thing as log base e. So if I rewrite this, this is the same thing as log base e of 9x squared plus 1. And this, again, is the little sad face rule where it cancels. So you just get 9x squared plus 1 dx. So can we do this in our head without me breaking it up? What would this one be? 9x what? Right, so the 9's still chilling. And then this would be plus what? What's the integral of 1? X plus c. So 9 divided by 3, yep, 3x to the third plus x plus c. Yep, I'm okay with you not, like, if you can go from here to here in your head, I'm totally fine, okay? Now you can show your steps too. If you want to show your steps, that's fine too. And then go from there. All right, 2 left and I'll be done for today. And I'm going to do the back half with fourth period, so I'll have it. So 2 left. Let's look at number 13. So the integral of dx over 3x plus 6. All right, what do y'all think your u would be here? Yeah, 3x plus 6. So then your du, because I can kind of see it's like a 1 over u problem. This would be 3 dx, right? So then du over 3 equals dx. So I'm going to write this as like 1 over u, right? Because this is u, and then my dx times dx, right? I just kind of broke it up to be 1 over 3x plus 6 times dx. So 1 over u, and then my dx is du over 3. Did everybody see how I did that? Because that's the same thing as dx in the numerator. And then factor out that 1/3. And the integral of 1 over u is ln of u. And I'll go ahead and plug in my u. Oops. There we go. Ta-da, ta-da. Yes. Go ahead. Last one, guys, we'll do for today is number 14. So I have the integral of x over x squared plus 1 dx. So what do y'all think my u is here? Usually what the denominator is, right? So this would be x squared plus 1. So du would be 2x dx. And that's good because I want the x's to cancel out, right? Because if I solve for dx, I get du over 2x equals dx. And that means my x's will cancel out. So when I rewrite, let's see, this will be x over x squared plus 1. That's what, u? And then my dx is du over 2x. So I can see, oh yay, my x's cancel. Pull out that 1/2. I get 1 over u du, which is then ln of u plus c. So I get 1/2 ln of x squared plus 1 plus c. All right, guys, that is your review, first part of your review. I'll go ahead and stop there because I know my voice gets kind of boring.